So today we are going to discuss about roots of quadratic equations. So first of all, we say the quadratic equation is an equation in the form ax squared plus bx plus c equaling to 0. And we said this equation is satisfied by two values of x. And these two values of x are the ones we call the roots of the quadratic equation. So after solving this quadratic equation and we obtain the two values, then those two values are known as the roots of the quadratic equation. For example, if we could take a simple example of x squared minus 5x say plus then plus 6 equaling to 0. So once we solve this equation, we shall obtain two values of x. So for example, we shall have our factors as 3 and 2 that we multiply to give us 6, and when we add them they give us 5. So instead of writing 5, we shall write them in terms of 3 and 2, and then we add 6 and say this is equal to 0. Then from there we shall do the grouping. So we shall do the grouping. So we are going to say x squared plus 3x, that is one pair. Then we add 2x plus 6, that would be the second pair. Equate this to 0. So once that is done, we are going to identify the common factor in the first bracket and the common factor in the second bracket. So that will give us the common factor in the first bracket is x. So that will be x into x plus 3. Then in the second bracket, the common factor will be 2. So once it is pulled out, so we also remain with x plus 3 equaling to 0. So the x plus 3 as well becomes a common factor. So we can write this as x plus 2 into x plus 3 equaling to 0. So now from here we can say either x plus 2 is equal to 0, and once the 2 crosses the equal signs, then x becomes equal to -2, or x plus 3 is equal to 0 and x would give us -3. So these two values here are what we call the roots of the quadratic equation. And the quadratic equation always has two roots. So that is how we find this. So for our emphasis of the roots of quadratic equation, we can now try to find out whether if we begin with x equaling to -3 and x equaling to -2, whether we can get back to this equation. So we can as well try it out and see. So our x is equal to -3 and our x as well is equal to 2. So we are now going to work backwards. So we are going to bring the 3 here. So it will become plus 3 is equal to 0. We are working backwards. X plus 2 is equal to 0. So here it will be x plus 3 into x plus 2 is equal to 0. So remember, from here we say either, and then we go to these upper steps. Then here we can now multiply x into x plus 2, then plus 3 into x plus 2. Are you seeing us going backwards? So here we are able to say x times x is x squared, x times 2 is 2x, x times 3 is 3x, and 3 times 2 is 6, equaling to 0. So now we write x squared plus, so 2x plus 3x gives us 5x, then plus 6 is equal to 0. So still, when if we work backwards, we are going to still get the same equation as we had at first. So that means we can as well work backwards. So let us now try to find a general formula that we can use to simplify this work of forming a quadratic equation when we are given the two roots, or when we are given an equation and then we are requested to find the sum, the product, and etc. So we can proceed. So we are going to begin by letting our equation A, x squared plus bx plus c equaling to 0. So it is going to have roots which are alpha and beta. Okay, so we are now going to say, so we are going to still work backwards. So if the roots are alpha and beta, that means x is equal to alpha and x is as well equal to beta. So working backwards, we shall have x minus alpha, and then here we shall have x, so this will be equal to 0, minus beta, still this equaling to 0. Then another step, we'll have x minus alpha, so we multiply the 2 into x minus beta, and this will be equal to 0. Then here we open brackets, so x into x minus beta, then minus alpha into x minus beta, and this will be equal to 0. So x times x gives me x squared minus x beta, then here it will be minus x alpha and plus alpha beta is equal to 0. So we can see that this one here has a common term, which is x, so we can just factorize it out. So we have x squared minus, okay, so we can begin with alpha plus beta, then times x, then plus alpha beta, and we say this is equal to 0. So the alpha and beta are the roots of the equation. So if I rewrite the equation here, x squared minus alpha plus beta x plus alpha beta is equal to 0. So this will represent the sum of roots. And this one here will represent product of roots because they are multiplied. They are alpha times beta. So this is the general equation that we shall use to deal with the roots of quadratic equations, and we shall find our work very simplified. So so if we work out an example where we had the roots are 3 and 2, so we just find, let me bring another one. So roots 3 and 2. So what we would do is to find the sum of roots, which would be 3 plus 2, and this will give us 5, and then we get product. This will be 3 times 2 equaling to 6, and then we would substitute in the formula x squared minus sum of roots. So this is a general formula times x, then plus product roots is equal to 0. So when we substitute in this general formula, we are going to have x squared minus x squared minus sum of roots is 5 times x plus product, which is 6, will be equal to 0. So once we find, so this would be the equation, the quadratic equation whose roots are 3 and 2. I hope that is okay. So let me proceed. So when we are given equations, given the following equations, find the sum of roots and product of roots. So our first equation is 3x squared plus 2x plus 7 equaling to 0. So to find okay, something I did. Okay, let me first. So we have seen that sum of roots, the general formula is x squared minus sum of roots times x plus product is equal to 0. So we can also generalize this x squared plus bx plus c equaling to 0. So we can as well have it in this form where x has a coefficient of 1. So that means we are going to divide by a throughout here. Here by a. So that this formula will now be x squared plus b over a x plus c over a is equal to 0. So if we compare it with the previous equation, where we had x squared minus alpha plus beta x plus alpha beta is equal to 0. So if we compare these two equations, this b over a would be equal to negative alpha. So negative alpha plus beta is equal to b over a. So dividing by negative would give us alpha plus beta, which is the sum of roots as negative b divided by a. And then c over a would be equal to alpha beta, which is the sum would be equal to c divided by a. So we are going to use these simple formulas here to find the product and sum of roots when we are given quadratic equations. So still I'm going to have my equation 3x squared plus 2x plus 7 equaling to 0. So I'm going to begin by dividing by 3. So divide by 3, divide by 3, divide by 3, divide by 3. So this would give me x squared plus 2 over 3 x plus 7 over 3. This would be equal to 0. So my sum of roots would now be equal to negative. So sum of roots is equal to a negative b over a. So that would be negative 2 over 3. And then product of roots equal to c over a, which is still same as 7 divided by 3. So directly from here, you would say from the equation 3x squared without dividing, a is 3, b is 2, and c is 7. So sum of roots is equal to negative b over a. This you can say is negative 2 over 3. And then product would be c over a. And this would be just simply be 7 divided by 3. So that is how we find the sum and product when we are given quadratic equation, sum product of the roots. Okay, let us proceed and do another one. 2x squared 2x squared plus x minus 7 is equal to 0. So our a is 2, our b is 1, and c is negative 7. So what we do is we are going to say sum of roots is equal to negative b over a, which is equal to negative 1 divided by 2. Then product of roots C over A, which is the same as -7 divided by 3. No, divided by 2, sorry. That. So let us have the last one there. The last one on that. We can have 5 squared plus 11x plus 3 is equal to 0. So A is 5, B is 11, and C is 3. So sum of roots is equal to -b over A. So this would be -11 divided by 5. Then product is equal to C over A, and that would be 3 divided by 5. So that is that on how we find the sum and product of roots when we are given quadratic equations. Let us briefly look at the formation of a quadratic equation given the roots. So which we had just seen one example. So let us also find more examples. Okay, so we are going to form an equation, a quadratic equation whose roots are 3 over 4 and -1/2. So first of all, we need to find the sum of roots. And this would be sum is 3 over 4 plus -1/2. So this is the same as 3 over 4 minus 1/2. So if we do a simple LCM, so this would be 4, 3 minus 4 divided by 2, 2 times 1, 2. So this would be the same as 1 over 4. And then we find the product of roots. And this would be 3 over 4. So multiply this by -1/2. And that will give us -3 divided by 8. And then after that, we substitute in the general equation, which is x squared minus sum of roots times x plus product of roots. Put this to 0. So this would be x squared minus sum of roots. So the sum of roots is 1 over 4 times x plus product, which is -3 over 8. So we can write this as x squared is 1 over 4x minus 3 over 8 is equal to 0. Let me just cross check to find out if I've written the exact thing. Yes. So here we are going to multiply every term here by 8 to remove the fraction, and that would be 8x squared, 8x squared minus 8 times 1 over 4 x minus 3 over 8 times 8 is equal to 0 times 8. So this would be 8x squared. So here is 1, here is 2, minus 2x minus 3 is equal to 0. So that would be our equation, our quadratic equation, whose roots are 3 over 4 and negative a half. Yes, we can do more one. We possibly shall stop there. Find an equation whose roots are 1 over 3 and 1 over 4. So we are going to begin by finding the sum of the roots, which is 1 over 3 plus 1 over 4. The LCM is 12. This would be 4 plus 3. And this would be 7 divided by 12. Then we get the product, which is 1 over 3, 1 over 4. This simply gives us 1 over 12. So we substitute in the equation, in the general equation, x squared minus sum times x plus product, which is equal to 0. So we shall have x squared minus sum, which is 7 divided by 12, multiply this by x, plus product, which is 1 over 12. This gives us 0. So multiplying by 12 to remove the fraction, would have 12x squared minus 7x plus 1 is equal to 0. And that would be our quadratic equation. So I think for now we can stop there.